You ready for round two? I am. Okay, first line of defense with the tools that we have is to graph, and I have that graphed. So let's graph it. And we have, there it is, -4 and -1.236. That looks irrational to me. It looks like something got rounded. And +3.236. Those decimals look alike. But the point is, we know one root for sure. The other two, they are irrational, most likely irrational. So what we're going to do is, using the tools that we have, we're going to divide out that -4. So jumping back to what we have, we're going to go ahead, switch colors, and say our final answer will be green. Our final answer is -4. And then a couple other things, because we are looking for 3 solutions, right? We're looking for 3 roots, 3 x-intercepts. They are true x-intercepts. So how do we find the other 2? Now you could say, well, you already found them. So here's the deal. The directions on this say leave irrational roots in simplest radical form, and that's probably what we're dealing with here. So we need to find out exactly what they are. So let's find it. Purple. You're welcome. So we're going to take that -4. We are not going to change the sign of the -4. We're about to go into some synthetic division. We're not going to change the sign of the -4, but we're going to take that -4 because it was the root itself. That was not the factor. The factor would say x plus 4. We're going to take -4 and we're going to divide it out. This is where synthetic division comes in so handy. Okay, here's the deal. Because we have found a root, the remainder had better be 0. Better be. So I'm going to have a 16 here, and that's going to cancel. We won't do that yet, though. Should I switch colors slightly? Let's go to blue. Bring down your 1, multiply, put it there, add, multiply, put it there, add, 16. Ah, isn't that cute? Okay, so when we divide out this root, when we divide the factor of x plus 4, which means we use synthetic division with the -4. We're going to have 1x squared minus 2x minus 4, and that's what's left over. Now, I don't say that in a remainder sense, but that is our quotient, all right? We need to set that equal to 0 and solve it. So when we set that equal to 0, if you're like, let's factor it, good luck with that. Not everything factors. I don't know why that was so condescending. I'm sorry. You try factoring. It's not going to work. It's really not. Unless you start playing with some square roots, which is what we're going to run into. So our next line of defense is to use the quadratic formula. (b plus or minus the square root of b squared minus 4ac, all divided by 2a. So that's going to be, here's a, here's b, here's c. Take the signs with you as you go. A is 1, b is -2, which means -b is +2. Plus or minus the square root of b squared, so -2 squared, minus 4 times 1 times the -4. 1 times -4, all divided by 2 times 1. Here we go. Here we go. You will scroll up. All right, 4 minus -16, that's 20, and that's going to give me a 2 right there. All right, if you're wanting to reduce, let's not yet anyway. So our next line of defense is to simplify that square root of 20. And if you need a little refresher, let's do it over here in white so you can't see it. I'm kidding, let's do it over here. The square root of 20. Think of 2 numbers that multiply to give you 20. You're square rooting, so you're going to need a perfect square, like 4 times 5. So the square root of 4 is 2, the square root of 5 is truly irrational, and we'll leave it like that. So the square root of 20 breaks up into 2 times square root of 5. Switch colors again. We have 2 plus or minus 2 square root of 5 over 2. Okay, good to know. Can you reduce now? Sure can. And when you reduce, you divide every single term by the same thing. That does not mean you're going to divide the 2 and the 5, okay? This is all one term. You're dividing the 2. So when we do that, let's use red again. 2 goes into itself one time. 2 goes into itself one time. 2 goes into itself one time. And that's going to leave us with 1 plus or minus 1 square root of 5 over 1. We have 1 plus or minus the square root of 5. That is one of our final answers. Final answers are going to be in green in this case. We started that tradition with this problem. 1 plus or minus the square root of 5. If you typed 1 plus the square root of 5, you would get 2 point, what was it, like whatever it was on the graph. 2.136 I think is what it was. Let's find out. 3, way off, man. 3.236 is 1 plus the square root of 5, and then negative 1.236 is 1 minus the square root of 5. You have found your three solutions. It was negative 4, and then 1 plus or minus the square root of 5. So negative 4, 1 plus the square root of 5, 1 minus the square root of 5.